Hello, class and professor. My name is Roman, and for this week's presentation, I will be discussing the Bombardier CRJ 200 as outlined through the Delta Connection manual in the Express CRJ manual, Volume 1 and Volume 2. The subject I'd like to cover is going to be the pressurization system. Now, we're going to cover a couple different areas regarding pressurization. This is going to be the context of this presentation. So we're going to talk a little bit about pressurized cabins, some of the FAA requirements. We're going to talk a little bit about the CRJ's pressurized system. We're going to go into limitations, and then we're going to go into some controls and phases. And then I'll try to recap some of the reasons I like the pressurization system, and specifically in this CRJ. So what is pressurization? So as you see here, we have a display that shows a cabin door on a typical airplane. Now, we're all in the aviation. We're all in the aviation program here at Liberty University. So I'm sure most of us have been on an airplane and seen this cabin door. It's a pressurized door. Now, what exactly is pressurization in an airplane? Well, simply, it just allows us to be at higher altitudes of operation, even though we have lower pressure at higher altitudes. And the primary concern we have at higher altitudes is going to be hypoxia. Now, hypoxia is basically when the body lacks sufficient amount of oxygen or flow of oxygen. Although there are several types of hypoxia, such as stagnant hypoxia, histotoxic hypoxia, and anemic hypoxia, the one that that's gonna cover pressurization is going to be hypoxic hypoxia, and there is the same amount of oxygen at sea level as there is at higher altitudes, such as 32,000 feet. The primary difference is going to be that the air molecules are spread out more, so it's harder for the body to get the same amount of oxygen molecules in a smaller space as it is at higher altitudes. So there's two types of altitudes I want to go into. We have aircraft altitude, which is going to be the actual height above sea level, and then we have cabin altitude, and that's the cabin pressure in which the aircraft is pressurized. Now, how cabin pressurization works is it uses the air from the engine, and then it takes that air, it compresses it, goes through the AC system, and it causes the air to set to a certain specific pressurization. Now, each pressurization is a little different, but they all have common mechanisms, such as using bleed air when we talk about aircraft. Now, in terms of the FAA does have requirements for flying at higher altitudes and having additional oxygen when you are in a pressurized cabin. So, for example, a flight altitude above flight level 250, um, they must have at least 10 minutes of supplemental oxygen in addition to the oxygen requirements to satisfy paragraph A of this section. Is includes each occupant of the aircraft to use in the event of a descent that is necessitated by loss of cabin pressure. So simply what that means is the FAA already has oxygen requirements for specific altitudes. Like there's an oxygen requirement starting at 12,000 feet, going up to 14,000 feet, and each additional level has a different oxygen requirement. So even if you're in a pressurized cabin, you still have to meet those requirements, and even though you have a pressurized cabin. All right. So let's talk specifically about the CRJ. So a little history about the CRJ. It's designed and manufactured by Bombardier Aerospace. It's been manufactured since the 1980s to present. So that lets you know it's a popular aircraft used by a lot of regional airlines. As we see here, we actually have a photograph of one from Delta Connections. The minimum flight crew for this aircraft is going to be one pilot and one co-pilot, although sometimes there's a jump seat pilot available as well. So let's talk about some of the phases and controls for the CRJ. So it has a pressurization system that uses controls of the escape of conditioned air from the occupied area. So this pressurization system includes two identical controllers. One controller is active at all times. So the second one is basically a backup, a standby controller, and it automatically assumes pressurization control. So with that being said, it's basically just a backup system to ensure that you don't lose pressurization at higher altitudes. Another feature that this aircraft has is it has an automatic mode, which controls pressurization in four different phases of flight. So the first phase of flight is going to be the ground phase. So obviously, the pressure is going to match the ground level or sea level. Then the takeoff phase, the system starts to adjust and begins to pressurize. And then we get to the climb cruise phase where the pressurization system is basically in a steady state. Then you have the landing phase. And the landing phase is interesting because you are descending through several flight levels. More than likely, you're going to be flying at flight level 350. And as you descend through these different altitudes, the pressurization system is adjusting the pressure as we get closer to sea level or whatever the altitude is. The altitude is at your landing location. Now, with that being considered, you may notice, obviously, when you are in a pressurized aircraft, you do get some certain simulating systems, such as you may have to yawn or chew gum to get rid of that additional pressure that you're feeling. But that's common in all aircrafts, whether it's pressurized or unpressurized. So here are some of the limitations of the pressurization system in the CRJ. So the maximum relief differential is 8.7 psi with a maximum of negative 0.5 psi. So as we talked about before, it has different phases, and you can see that it has a specific psi for taxi, takeoff, and landing. Also, it must be completely depressurized before any of the doors are open. And also, the pressurization system must not be operated to 1,500 feet when the system is in manual mode. And then here, we have some additional limitations for minimum crew oxygen pressure. As you can see, the pressure needs to be adjusted based on the altitude. And as we know, it is a minimum of 2 crew members. And you see there's differences in minimum pressure based on the temperature. So in summary, the CRJ has a more advanced pressurization system than, let's say, a non-commercial aircraft. It allows you to fly at higher altitudes, and it does meet the FAA minimum requirements. The pressurization system just is a unique system to me because it allows you to do more as a pilot, traverse higher altitudes, and climb and descend into different airspace. So once again, that is the pressurization system, and thank you for watching my presentation.